Hello everyone, this is Ajay and you are welcome on my YouTube channel which is Math Cafe. So this one is the part 6 of our topic which is matrix. So this video is all about important definitions. Alright, so we will be seeing some definitions like idempotent matrix, second one is nilpotent matrix, third one will be periodic matrix, and fourth one will be involuntary matrix. Let's proceed one by one. So first definition is idempotent matrix. So a matrix A is called idempotent matrix if A square equal to A. So a square matrix A is called idempotent matrix if A square will be equal to A. If A square is A, we have seen in the definition, if I'm multiplying a matrix A on both sides, then A cube will become A square. That is also A. If I'm multiplying matrix A on both sides, then A power 4 will be equal to A square. That will become A, and A power 5 will also become A. Alright. So I can observe that A power any natural number, that will become matrix A where n is greater than equal to 2 and n belongs to natural number. Hope you understand this. If I'm solving I plus A raised to n, so this will become nc0 A raised to n plus nc1 A raised to n minus 1 plus nc2 A raised to n minus 2 and so on, and cn I. Alright, so A raised to n will become n A, so nc0 that will become A plus nc1, so A raised to n minus 1 will become A plus nc2 A raised to n minus 2 will also become A. Alright, so in the last we will write ncn multiplied by I. So we can take common in the all the terms except the last term. So I am taking common, so we will be left with nc0 plus nc1 plus nc2, and in the last nc n minus 1. Alright, plus this is ncn is 1, so this is just I. So I am taking I at first place, so I plus A multiplied by this is nothing but 2 power n minus 1, 2 to the power n minus 1. Alright, so I plus A raised to n will become I plus A multiplied by 2 power n minus 1. So this will be valid only for idempotent matrix. Okay, hope you understand this. So let's proceed with the another definition, which is nilpotent matrix. So second definition is nilpotent matrix. So any square matrix A will be called nilpotent matrix if A raised to P equal to 0. So any square matrix, a square matrix A will be called Nilpotent matrix if a raised to p will become 0. So a raised to p is 0, then this type of matrix, this type of square matrix is called nilpotent matrix. But a raised to p minus 1 should not be equal to 0, where p is greater than equal to 2 and p belongs to any natural number. All right. So here p is called index of nilpotency. Here p is called index of nilpotency. All right. So let's take an example here. Let's say any matrix A is given 1, 2, 0, 1. All right. And we need to find the value of A power 2007. All right. So let's proceed with the solutions. So in this type of questions, we will write matrix A as I plus B. So we will write matrix A as I plus another matrix B. So this matrix can be represented as I. I means identity matrix, that will be of 2 cross 2. So 1, 0, 0, 1. And this matrix can be dissolved into another matrix B. So 1 and 1 will be as it is. So I can write here 0, 0, 2 and 0. All right. So sum of both the matrices will be A. All right. So this is in the form of I plus B. So if this matrix is B, then if I multiply B to B, so if I'm going to find matrix B square, so that will be 0, 0, 2, 0 multiplied by 0, 0, 2, 0. So we have seen in previous lecture matrix multiplication. So we will do matrix multiplication in row by column method. So 0 multiplied by 0 and 0 multiplied by 2. So 0 plus 0. 0 multiplied by 0 and 0 multiplied by 0 will become 0 plus 0. 2 multiplied by 0 and 0 multiplied by 2, that is 0 plus 0, and 2 multiplied by 0 and 0 multiplied by 0, that is 0 plus 0. So this is a 0 matrix of order 2 cross 2. All right. So here actually B square is 0 matrix. Here B square is 0 matrix, and we need to find A power 2007. So this can be expressed as I plus B power 2007. So this expression can be expressed as 2007 C0 multiplied by I plus 2007 C1 multiplied by B plus 2007 C2 multiplied by B square, and so on. And in the last 2007 C2007 and B power 2007. All right. As we know that B square is equal to 0, then B cube, B power 4, B power 5 all will become 0. So here 200 C0 is 1. So 1 multiplied by I will become I, plus 2007 C1 is 2007 multiplied by matrix B, plus here B square is 0 matrix. So 0 matrix is multiplied by any number will become 0 matrix. So all these matrices are 0 matrix. All right. So I can write it all the sum of all the matrices as 0. So finally I will get I plus 2007 matrix B. All right. So here I is of order 2 cross 2. So I can write it as 1001 plus 2007, and matrix B is 0020. All right. 0020 0. Okay, finally this is as it is 1 0 0 1, and we can multiply by scalar quantity. So that is 0 0, that will become 4 0 1 4, and that is 0. So we can add both the matrices by summation of corresponding elements. So 1 plus 0 will be is 1, 0 plus 0 will be 0, 0 plus 4 0 1 4 will be 4 0 1 4, and 1 plus 0 will be 1. So here a power 2007 will be this matrix. Alright, so hope you understand this. Actually, we can solve this question by another method also. So let's see method number 2. So it is given in the question that any matrix A is 1 0 2 1. So let's find A square. 1 0 2 1 multiplied by 1 0 2 1. Alright, so this will become we will do multiplication of both matrices by row column method. So 1 multiplied by 1, that is 1, plus 0 multiplied by 2, that is 0. 1 multiplied by 0, that is 0, and 0 multiplied by 1, that is 0. Alright, 2 multiplied by 1, that is 2, and 1 multiplied by 2, that is 2. So 2 multiplied by 0, that is 0, and 1 multiplied by 1, that is 1. Alright, so A square we obtained 1 0 4 1. Alright, so let's find a value of A cube. So A cube will be A square multiplied by A. So A square is 1 0 4 1, and matrix A is 1 0 2 1. So let's do the multiplication of two matrices in through row by column method. So 1 multiplied by 1, that is 1, 0 multiplied by 2, that is 0. So 1 plus 0 is 1. 1 multiplied by 0, that is 0, 0 multiplied by 1, that is 0. So 0 plus 0 will be 0. 4 multiplied by 1, 4, and 1 multiplied by 2, 2. 4 plus 2 is 6. 4 multiplied by 0, that is 0, and 1 multiplied by 1, that is 1. So 1 plus 0 will be 1. So here A cube is 1. So let's see a pattern here that in A and A square in A cube. In A square and A cube, three terms are same. 1, 0, and 1. Alright. In A square, it is common 1 0 and 1. In A cube, it is common 1 0 and 1. Only this element is going to change. So let's see the pattern of this element. This is 2 multiplied by 1. This is 2 multiplied by 2, and this is 2 multiplied by 3. If we are going to find A, in A matrix, this element is 2 multiplied by 1. In A square matrix, this element is 2 multiplied by 2. In A cube matrix, this element is 2 multiplied by 3. So we can find that in A power 2007, so this matrix will be, these three elements will be common, and this element will be multiplied by 2 multiplication of 2007, that is 4014. Alright, so we can find A power 2007 by second method also. Hope you understand this method. Alright, so let's proceed with another example. Let's say it is given that a matrix A is 1 0 0 4 1 0 16 4 1. Then we need to find value of A raised to 50. Alright, so let's proceed with the solutions. So first of all, in this type of problems, we will convert matrix A in the form of I plus B. Alright, so here I is any identity matrix of order 3 cross 3. So that is 1 0 0 0 1 0 0 0 1. And another matrix B will be, there is 1, so we have already 1, so corresponding element will be 0. And here the element will be also 0, and here also 0. So the 0 is there, so there will be 4. And here 0, again 0. So there will be 16, so 0 plus 16 is 16. So there will be 16, here 4, and that is 0. So this is I and this is matrix B. So in the second step we will multiply B by B. So we will try to get the value of B square. Alright, so that is 0 0 0 4 0 0 16 4 0. So this matrix is multiplied by the same matrix 0 0 0 4 0 0 16 4 0. Alright, so we will do the multiplication through row by column method. Alright, so here 0 0 0 multiplied by 0 4 16, that will become 0. So 0 0 0 is multiplied by column 2, that will also become 0, and with the column 3, that will also become 0. Alright, so if 4 0 0 is multiplied by 0 4 16, that will become 0. 4 0 0 is multiplied by 0 0 4, that will also become 0, and that will also become 0. If 16 4 0 is multiplied by 0 4 16, then that will become 16 multiplied by 0 is 0, 4 multiplied by 4 is 16, and 0 multiplied by 16 is 0. So finally we will get here 16. And this is multiplied by this, that will become 0, and this is multiplied by this, that will also become 0. So finally we got matrix B square as this. Alright, now we will try to find matrix B cube. So we will multiply B square by B. So B matrix is 0 0 0 4 0 0 16 4 0. Alright, so let's do this matrix multiplication through row by column method. So first row is multiplied by first column, that will become 0. First row is multiplied by second column, 0. First row is multiplied by third column, 0. And second row is multiplied by first column, 0 0 0. If third row is multiplied by first column, that will also become 0. And in the remaining two cases, all the terms will be 0. So finally we got B cube as 0 matrix. Alright, so B4, B5 and so on will also be 0. And we need to find A raised to 50. So A is I in the form of I plus B raised to 50. So I can express this term as 50C0I plus 50C1B plus 50C2B square plus 50C3B cube, and so on. In the last term will be 50C50B raised to 50. As we know that B cube is 0 matrix, so remaining term will also be 0. So B power 4, B power 5 and so on, B raised to 50 will also be 0 matrix. Alright, so finally 1 multiplied by I, that will become I. 50 C1 is 50 times of B, and 50 C2 is 1 2 to 5, 1 2 to 5, that is multiplied by B square, and remaining terms are 0 matrix. Alright, so I is of order 3 cross 3, so that is 1 0 0 0 1 0 0 0 1 plus 50 times of B, and matrix B is matrix B is 0 0 0 4 0 0 16 4 0. Alright, so 0 0 0 4 0 0 16 4 0 plus 1 2 2 5 multiplied by b square, and b square matrix is 0 0 0 0 0 0 16 0 0 0 0 0 0 0 0 16 0 0. All right, that is a raised to 50. So finally a raised to 50 will be identity matrix is as it is 1 0 0 0 1 0 and 0 0 1. So we will multiply all the terms by 50, so that will become 0 0 0, that is 200 0 0, and that will become 800, and that is 200, and that is 0. All right, so plus we will multiply all the terms by 1225, so 0 0 0 0 0 0, and that will become 16 multiplied by 1225, and again 0 0. All right, so we are going to add all the three matrices. So 1 plus 0 plus 0 will be 1, again 0 0, so 0 plus 200 plus 0, that is 200, again 1 and 0. All right, 0 plus 800 plus this, that will become 20400, and 0 plus 200 plus 0, that is 200, 1 plus 0 plus 0, that is 1. So this is our final answer. Hope you understand this. Let's see the next definition, that is periodic matrix. So a square matrix is called periodic matrix if square matrix A is called periodic matrix if A multiplied by A raised to K, that is the matrix A itself. All right, if this equation is satisfying, then this matrix A is called periodic matrix, where K is period of matrix, where K is period of matrix A. Okay, in the least case. All right, if it is given that A raised to 4 is A, then find period. Let's take it as a question. So solution will be A multiplied by A cube, that is A, so period will be 3. Okay, so here period will be 3. This is nothing but period of the matrix A. Okay, hope you understand this. So let's see the last definition, that is involuntary matrix. So in the fourth point, involuntary matrix. So A square matrix A is called involuntary matrix if A square is I, as simple as that. So A square matrix is called involuntary matrix if A square equal to I, that is identity matrix. So A will be called in this case involuntary matrix. So if A square is equal to I, then A cube will be equal to A. All right, If I multiply a on both sides, then a power 4 will be a square, and again a square is I, so a power 4 will be I, and a power 5 will be a, and again a power 6 will be a square, that is I. So what we observe, that if a raised to the power is even, a raised to the power is even, then the resultant value will be I, and if a to the power is odd, then resultant value will be a. Alright, so final conclusion is that if a to the power is even, if a to the power is even, then the resultant value will be I. If a to the power is odd, that is 2n minus 1, then the resultant value will be the matrix itself, where n is any natural number. Alright, so let's see a question here. If it is given in the question that if A is an involutory matrix then find the value of first one is a raised to 2004, and in the second part we need to find the value of a raised to 4007. So let's proceed with the solutions. Alright, as we know that if A is involutory matrix, then if power of A is even, then the resultant value will be I, and if power is odd, then the resultant value will be matrix itself. Hope you understand this lecture. If you still have any doubt, you may ask in the comment section, and see you soon in the next video. Till then, bye, take care and keep learning.